Hey everybody, this is Andrew from AeroGrow. You know, when most people get a printer, they buy it either online or they're given one as a gift, it's typically 0.4 millimeter or smaller that they're printing in. So some of them I think are 0.2 right off the shelf, but 0.4 is pretty typical. So if you're wanting to print something either faster, because we all know how much time and patience it takes 3D printing, if you want to print something faster, the only way to go is to print bigger. You have to go with a larger nozzle size, either a 0.6, a 0.8, you can go all the way up to a 1.2 on a printer such as this with a bit of modification. That's pushing it a bit. So far at AeroGrow, I've needed to print in both 0.6 and 0.8. I found printing in 0.6 to be a nice step up. It was significantly faster. But it didn't come with some of the more annoying complexities that you have when you jump up to 0.8, as far as being able to keep up with the heat cycling, being able to keep that hot end hot enough to actually melt that filament fast enough to push it out of a big opening, like a 0.8 millimeter opening. You have to have a really powerful hot end to do that. And this printer did come with a nice, pretty powerful hot end, all metal hot end. So it was up to the task, but 0.8 was pushing it a bit. 0.6 is where I decided to sit for a while. Again, some of the problems you'll run into is having to do with the delivery of the filament through that hot end. You probably, I don't know if you can hear this on microphone. Let's see if I can pick it up. The clicking sound coming from the filament motor here, the extruder motor. Take a listen. So I don't know if you can hear that, but that clicking sound, I've kind of gotten used to it at this point, because for me there's just almost no way around it. I have to go so slow that it's just annoying. So what that indicates, though, is that there's a problem getting that filament through the nozzle fast enough, according to what the motor wants to do. The motor wants to deliver that filament smoothly, and when it's clicking, it means it's encountering resistance, as we know, right? The resistance can either be from the Bowden tube. Mine's not zip tied right now because I just replaced this literally 10 minutes ago, but the tube can be a point of resistance. That's why I just replaced mine. The motor can be dirty, actually. In the back here on the gears, where the gears meet the filament, there can be bits of anything, really, dust, bits of filament, anything that comes off of the hotbed here. The build plate here can get stuck in the gears there, and that can cause you resistance, and that can make the filament skip like that. There can be dirt on the filament. I've never run into this before, but there can apparently be dirt on the filament, which actually causes the opposite problem. It causes the filament to slip from between the gears. And in that case, I'm not sure if you would hear a clicking or not. I don't know. Somebody maybe want to leave a comment. Would you hear a clicking if there was dust on the filament and that was the issue? I'm not sure. Maybe you can answer that for me. I have not run into that yet, so that's not an issue. But what I do to overcome some of those issues is, first of all, I turn the speed down manually most of the time. Like, I'll have the speed set through Simplify 3D for a certain millimeter per second, but the fact is, usually I'm going on to the panel here on the printer itself, and I'm slowing it down to, let's see, right now, under the tune settings, and this is an Ender 5 Pro. Under the speed, I'm at 48 for the speed, for example, so I slowed it down to like half speed pretty much. The flow, I have the flow cranked up to 119 right now. Comment if you want. There are reasons for that. There's a much longer story. I know that's not the way to go as far as increasing flow, but for this particular experiment, I had to do that. So we can talk about flow rates later, but basically, I increase my flow rate, I increase my temperature, and I drop my speed, and those three elements together typically will allow me to push filament through a 0.6 millimeter hot end, all metal hot end, at a pretty consistent, reliable rate. These parts are very strong, even at 15 and 20% infill. I have no problems with adhesion or anything like that. They're very clean, little bit of stringing at the moment. It doesn't bother me too much. I just trim that off afterwards. It's not a big deal. But other than that, I'm so pleased with how this is working right now. So please don't forget to like and subscribe. In the comments, want to tell me about what you're experimenting with 0.6 and 0.8 millimeter large format printing, or anything you'd like me to talk about here as far as my experience with printing in larger nozzle sizes and printing higher density pieces and pieces for use outdoors, for example, or in automotive uses is another good example of where you might be wanting to go with a larger nozzle size. So like and subscribe. Catch you on the next video. Thanks for watching.